In this video, I'm going to look at a quick way to sketch the graph of a rational function that is in simplified form. So a rational function, here's the general definition, is a function of the form n of x over d of x, where n and d are polynomials, and of course the denominator cannot be 0. And for this particular video, we're going to consider the rational function r of x here, defined this way, where the degree of the numerator is less than the degree of the denominator. And the function is in simplified form. So that means there are no common factors with the numerator and the denominator. And the most simple one you can have, start off with, say, y equal 1 over x. The numerator is constant, so it has degree 0. The denominator has x to the first, so the degree is 1, 0 less than 1, so that qualifies as the type we're going to consider. Okay, so first thing we're going to look at is the x and the y-intercept. Okay, so the x-intercept is found by replacing the y by 0. And then you solve for x. Okay. But if I try to solve that for x, multiplying by x, I get 0 equal to 1 contradiction. So it has no x-intercept. The y-intercept is found by replacing the x by 0. Okay, if I replace the x by 0, I get 1 divided by 0, undefined. So this particular one has no x-intercept and no y-intercept. Okay. Now, for the vertical asymptote, you can see that its x increases 1, 2, 3, 4, 1,000, or decreases -1, -100, -1,000. The denominator gets large in absolute value, so this thing is approaching 0. Okay, so for these type of problems, typically you're going to have a horizontal asymptote at y equal to 0. Now, any number that makes the denominator 0 is where the function is undefined, so that's where we expect to have vertical asymptotes. Replacing the x by 0, again I get 1 over 0, so x equals 0 is a vertical asymptote. Okay, so again we find the x and the y-intercept if we have any. Then we determine the equations of the vertical and horizontal asymptotes. And then we're going to plot any number that makes the numerator or denominator 0. In this case, it's only 1. The denominator is 0 at 1. And you simply determine the sign of this function to the right and to the left of that number. If I pick numbers larger than 0, 1, 2, 5, 100, this is always going to be positive. If I pick numbers less than 0, -1/2, -1, -2, I have 1 divided by a negative. Over here it's going to be negative. Okay, so that simply tells you that to the right of 0, the y values are positive. The graph is above the x-axis. To the left of 0, the y value is negative. The graph is below the x-axis. Okay, so then we draw the graph of the vertical asymptote. Usually we draw it as a broken or dotted line. So in this case, it's the vertical asymptote is the x-axis, and the vertical asymptote is the y-axis, and the horizontal asymptote, y equals 0, is the x-axis. Okay, so then let's use this number line and just common sense. The graph is above on this side, and I have a vertical and a horizontal asymptote, so approach it, or just sketch the graph so it approaches both. Okay, to the left of 0, I have a negative over here in the number line. The graph is below the x-axis. Again, I have a horizontal and a vertical. Draw the graph so it approaches both. And this gives you a rough sketch of the graph. Okay, you could actually plug in some values to get some points just for accuracy. Notice if I replace the x by 1 here, I get 1, so the graph actually passes to this point, so it actually comes a little bit lower. But this is just a sketch of the graph. Okay, the graph is never going to cross the vertical asymptote because it's undefined at those values. It may cross the horizontal. Now, in this particular case, we know it doesn't cross the horizontal because the horizontal is y equals 0, so replace the y by 0, there's no value for x. Okay, that's one way you can check to make sure. Okay, but just use common sense when it comes to sketching your graph. Okay, let's delete this. Okay, now we look at this one. Y equal to 1 over x minus 2. Okay, so let's do the y-intercept first. For the y-intercept, replace the x by 0. And you can see if I replace the x by 0, I get 1 divided by negative 2, so I get a negative 1/2. Okay, so we do have a y-intercept here at 0, negative 1/2. To find the x-intercept, replace the y by 0. Solve for x, but if I replace the y by 0, I get 0 equal to 1 over x minus 2. If I multiply by x minus 2, I get 0 equal to 1. Okay, so in this case then, I'm going to have none. No x-intercept. Okay. Okay, for the vertical asymptote, again, any number that makes the denominator 0 for these types of problems we're considering, it's going to lead to a vertical asymptote. So the denominator is 0 at 2, so x equals 2. The vertical asymptote. For these types of problems, again, a horizontal asymptote will always be the x-axis, or y equals 0. Okay? And then for your number line, I get over here, plot the numbers that make the numerator or denominator 0. In this case, it's 2. So again, pick numbers to the right of 2, 3, 4, 5, and so forth, and I get a positive. You can see if you pick numbers less than 2, say 1, 0, negative 1, you're going to get a positive divided by a negative. So in this case, I'm going to get a negative. So again, the positive tells you the graph is above because the y value is positive, and a negative tells you that it's below the x-axis. And then we just plot the asymptote. So again, at 2, x equal to 2, so I draw the graph of that asymptote. And y equals 0, that's the x-axis. Okay, and then again, use the number line and just common sense. To the right of 2, that's just to the right of this asymptote, is positive, so the graph has to be above. I have a vertical and horizontal, so just draw it so it approaches both. Okay. To the left of 2, I have negative, so the graph should be below, and I know it passes through the point 0, negative 1/2, so I plot that point right there, and then again, draw it so it approaches the asymptotes. Okay, so it's going to go something like that, just a rough sketch here. That's what your graph looks like. Clear this. Okay. For this one, to get the y-intercept, I replace the x by 0, but then I get division by 0. So this one's undefined, so I don't have any. To get the x-intercept, I replace the y by 0, but then that's going to lead to the contradiction, 0 equal to 2. So this one has none. Okay, no x-intercept, no y-intercept. The vertical asymptote is x equals 0 because that's the number that makes the denominator 0. And again, the horizontal asymptote for the types we're considering is always going to be y equals 0. Okay. Keep in mind, it's the types we're considering. There's variations of these. We'll look at some of those in another video. Okay. And then for the number line, the number that makes the denominator 0 is 0. So you can see, because of the square on that x, no matter what number I plug in there, whether it's positive or negative, when I square it, I get a positive. So here I have a positive on both sides. Okay. So this tells me the graph stays strictly above the x-axis. Okay. So again, the vertical asymptote is the y-axis. The horizontal is the x-axis. Again, to the right of 0, it's positive. I have a vertical and horizontal, so just draw the graphs that approaches both. And then to the left of 0, I also have a positive, so again, draw the graphs that approaches both. So we have a graph that looks like that. It approaches the y-axis from the right and from the left, but the graph doesn't touch it. And it approaches the x-axis, as shown here, but the graph stays strictly above the x-axis. And we know it doesn't cross the horizontal in this case, because when y is 0, I don't get a solution for x. Okay. So again, those are the steps that you would go through to sketch the graph. A quick sketch of the graph for a rational function that satisfies the conditions that I went over. Thanks for watching. We'll see you next time.